For this exercise, we're going to look at commercial fishing and kind of do a socio-ecological analysis. For this exercise, you're going to use the time slider, which helps you visualize time series GIS data. You can look at it over time. You can even export videos of changes in time so that you could put them, say, in a PowerPoint. Also, we're going to look at multi-dimensional data, which is becoming more popular because big data is increasingly used by people, and a way to package a data into a single file. And we'll talk about that when we get to it. So kind of the questions we're looking at is, people hearing that the commercial fisheries, the communities involved have changed over the years. And so we're going to use this Alaska Commercial Fisheries Entry Commission permit database, which goes back to 1980 to the present, to give us insights into how many permits each community has obtained over the years and the changes in those. And so if we look at the database, it's this Commercial Fisheries Entry Commission database, and there is a public database. Now this database, I don't know if it's like less than 3 or less than 8. If there's fewer than that, sometimes the communities are hidden because you could easily identify who's the person within a community that has a commercial fishing permit. So there are some limitations to this database. It's always good to contact the authors of a database to understand the biases, the particularities, of a database. But I've gone through and downloaded the data each year, so you can't do a range of years, unfortunately. You have to do each year, so 1980, 1981, 1982, and then I kind of process this using the command line on my computer and Excel and R into one file. So there was a lot of data cleanup that went into this to get the database that you're going to use. And some, you can't do an ArcGIS, so there are some limitations with ArcGIS. And then second, people have been mentioning that the waters are getting warmer, where they're fishing. So, most ground fisheries off the coast of Alaska are managed by the National Marine Fisheries Service. And, this is like part of NOAA. And we are going to use a giant database of sea surface temperatures that goes from 1940 through the present, to look at how temperatures have changed in July when people are out fishing. And so that database that you're going to use is from Copernicus, and it's ERA5 monthly average data. And so, if you've done any kind of climate change research, ERA, should be pretty familiar. We're going to use this, reanalysis and you can see the picture here of the data. So when you go to download data, what we're going to use is this monthly average reanalysis, and we're going to use sea surface temperature, and we're going to do all of the years, and we're only going to look at July. Let's kind of limit the data there, and then the whole world, and we're going to download something that's called a GRIB file. It is a type of raster, but it is a multi-dimensional raster. So what does that mean? It is basically a raster that has time stacked in it. So it has, in this case, I believe 83 years of data. We did, 1940 to 2022 for our analysis, but basically it has the world, and each of the years is kind of stacked on top of each other. So a lot of data in this single multi-dimensional raster data. And you'll see these netcdf files. So if you see these, that's what those are. HDF, that's a very common file type used by climate change scientists. Ours is a GRIB file. So you're going to be learning a lot of new stuff today, and kind of cutting edge stuff. All right, so you obviously have your guide that you can follow here that'll be posted on Blackboard, so you could go and download that. And as usual, the questions for your exercise are embedded within this document. And so I'm going to get this off to the side here and start up ArcGIS Pro. Okay. Alright, so I am going to start a new project. We call it Commercial Fishing. And I'm going to go, if I have like a projects folder, I would save it there. You know, I'm doing this for the class, so I am going to save it in my class folder. Alright, so I'm going to save it in here. Hit OK. Okay. Alright. Once this gets loaded on your computer, we're going to add in some data. So in your student data, you should have a communities layer, and you should have a summary DBF that I put together. That's interesting. It shouldn't be empty. Let's go in here. That one's also empty. Okay. Sometimes ArcGIS has some issues. Okay, so it's found the data in that one. Come back to the commercial fishing and see it has found the data here, and it has not. This sometimes happens, kind of weird. You look, I clearly have data in the student data file, so it is here. For some reason it is not finding it, so I'm just gonna close this and try again. Now it found it. Weirdnesses, weirdnesses. Alright, add the communities and add the permits 1980-2022 DBF. Okay, it didn't add the communities layer. So that means we should take a look at it and see what's going on. Communities layer does have 6 files with it. So it doesn't seem that we've dropped a file. Let's go, and you might not be having this problem, but I'm having this problem. I'm going to go, and I have a brand new computer, so I don't have any connections yet. So I'm going to add a folder here. Good review for you if you have not done this. So I'm going to add a connection to my Google Drive. Down to the class here. Okay, I see the communities layer there. I'm going to try to add it to the current map this way. Okay, for some reason it is not liking that communities layer. Let me try to add this one. It likes that one. So it doesn't like something about this communities layer. So I'm going to overwrite to this communities layer with this data, which I know is working. You do not have to do this because I will give you an actual working file. But just to show you, sometimes things don't go smoothly and you gotta play detective and figure out what in the heck is going on. interesting. It's showing me 2 communities. Save. I'm going to overwrite that. Yes. Okay. All right. So pretend that you have your communities layer added there. Okay. I'm going to look at the attribute layer of the communities. And I can see I have a name that's all in caps, and I have a name that is in proper case. This is important because ArcGIS is case sensitive. We're going to be doing some joins here, and if you try to join with this all uppercase, it's not going to work. You're going to have to use the one that's called name, which is in proper case. This also has the XY coordinates to it. One is in decimal degrees, this other one is in a different unit. And so we're going to need this to turn our non-spatial data into spatial data. So let's look at the permit database. Okay, huge database, over 700,000 records, but like I said, this is the community, this is all the permits from 1980 to 2022, and what they fished for, and the community. So the first thing that we need to do is we need to summarize this, because right now we eventually want a table that says how many permits were fished by a community each year. Okay, so we need to summarize. Right click and go to summarize, and we want to summarize by community, but we also want to summarize by year. And you have this pres column. Like I said, I always put like a presence field in my databases usually, so we're going to sum up this presence, which will give us a count. Okay, realistically you don't really need this presence. You could just pick anything and run this, because you're always going to get a frequency column, which is in a sense how many times this combination occurs in the database. And let's call this permits underscore 1980 on 2022, and we'll call it summary, and just save it to the default geodatabase that's created with your project. If you want to save this permanently, which probably would be good for the analysis, you would then navigate to a folder and save it in a specific folder and put .dbf or .csv at the end of it, depending on which kind of table you would want. So this is a very large database, so it will take a while to run. And it's running. Okay, so close down these tables. We'll look at our summary. Okay, so now we're down to 9,000 records, so a little bit more manageable. And as I mentioned, you can see this frequency and the sum presence are the exact same. One thing is that if we want to view changes over time in the number of permits, we got to think about visualization and how this might look. If you have a really wide spread of data, it's kind of hard to visualize the count. So for example, if we did this by size from like smallest to largest, it's going to be troublesome, because I bet you this data is pretty skewed. So what I want you to do is go and make a chart and do a histogram of this, and in that histogram look at the distribution, and I ask you how many communities have, how many records have one permit only of registration, and how many communities have over 3,000. That is a huge range to try to visualize. You will basically have probably a few communities that have big old blobs for a lot of permits, and then all these other ones that just have values of 1. Not very good way to visualize the data. So answer that question. Fortunately, I have created another summary database where we look at the percent of ownership within years. So how many, what percentage of permits were owned by ADAC station within 1980. The reason we want to use percent is because rather than going from 1 to over 3,000, all your data is going to be from 0 to 100%. So a much smaller range and a better way to visualize your data. So go back up to map and go to your folder, and you'll see this permits 1980_2022%. So add that. And this, is a limitation of ArcGIS. There's really no way to calculate up the percent. So I had to export this data, pull it into R, and run a script that would calculate the percentage within each year. So now you can see that ADAC within 1980 had less than 1% of permits in Alaska. But if we kind of, look through this, you'll see some higher ones. So let me do a select by attribute. Let's just look at 1980 here. And let's just show 1980. So 251 communities had permits in 1980. Let's try to sort. And no surprise, Anchorage had 11% of the permits in 1980. But we can deal with, a range of 100 to 0 much better than 1 to 3,000. So this is the one we're going to use, for visualizing how has the ownership of permits among communities changed over the years. So I want you to hit clear. We don't want to have a selection here. All right. So we have our data now, but it's not visual. It's just a table. And so I do have a question. The goal is to get this information assigned to these points so that we can look at the changes over the year. Really, we want to have, a point file that represents 1980, 1981, 1982. So my question to you is, why can't we do just a simple joining this non-spatial data to our community spatial data? I mean, we see name here, and we see community here. Why can't we join this non-spatial data to this community's layer and display the data? So before you go forward, where the answer will be revealed, think about it and try to answer that question. So since I'm telling you that's not the way to do this, one of the things that we have to do is we have to get this percentage field, which has 9,000 records, spatially visible. We notice that our communities has an XY coordinate. We want to join this community table to this permits table and grab this XY coordinates and then spatially display the data, because you can display XY data. So clicking on your permits with that one highlighted, go up to table and join, add a join. Alright, so we're going to join over our communities layer, and the field here is community, and the field here is name, not this name, because notice this is all uppercase, this is not, it is name. Very important. Okay. Alright, so we're doing the join. This data should show up here on our non-spatial table. So, okay. One of the things, that I had to do is I had to go through here and clean up some of this data within the commercial fishing database, because not all communities are spelled the same. For example, St. Paul might be the word Saint all spelled out, or it could just be ST period, Paul. So I did have to go through and do a little bit of cleanup for the major fishing communities, but there are some communities where okay, you're going to drop out. And so how can we find out which communities here did not get any spatial information assigned to them? because they're going to drop out when we go to make this data spatial. So what we're going to do is we're going to do a select by attributes. So select by attributes. Okay, and we want to find out which communities did not get data added to it. So what you can do is you can go down to, you know, some of the data that was joined. So this X point, this name, all of these are joined fields. These joined fields should be null if there is no data that was joined to them. So we can see ADAC was definitely in the database because it got an XY coordinate. Let's see what did not get data. So hit apply, and then go down here and look at your selection. And so this community of Alatac, I've never heard of, did not get any XY data. It's going to be lost. Amuk Pass is not in this database. If I come over here and I sort, see, I don't see the community of Alatac. I don't see the community of Amuk. So these are just communities that are going to fall by the wayside and be lost. I ask you, how many communities are we going to lose when we go to turn this data into spatial? So by now you should be pretty good about using the summarize to figure out how can we count up the number of communities that are going to be lost that have no XY coordinate when we're doing this operation. So please look at that and answer that question. Alright, so I'm going to close the attributes. I'm going to clear my selection, show all my records. Okay, so I can't display the XY data yet. When you go up to this, right click, and it says display XY data, that's what we're going to use. However, this is just a join, and it won't let you perform the operation on temporary join data. So we're going to export this as a new file, just so that we can make this join permanent and use our information. So I'm going to call this permits underscore 1980 underscore 2022 and then underscore XY, because it has the XY data with it, and it's just going to be saved to your temporary geodatabase with this project. So this will help make these fields that are joined on permanent. Okay, so we can close that. We'll look at our new data. Always good to just look at your data. And yep, the fields are there. Alright, so now turn off your communities layer. And let's go down to your XY data that you just did and say display XY data. So we're going to name this permits underscore 1980 underscore 2022, and we're going to put com after it for communities. Okay? Your X field is going to be your point X, your Y field will be your point Y, and your coordinate system is going to be the same one that your communities was in. So NAD 1983 Alaska Albers, and then hit OK. So that's what your information should all look like. And it's telling me that some of the communities were dropped because in fact they didn't have valid XY coordinates. They were, so we'll live with that. All right, so now we can see our data. These are the communities that have commercial fishing permits. So we're going to want to look at our attribute table, and I ask you how many rows are in this new database. So answer that. And if you didn't get the first question where we asked how come we couldn't just do a simple join to this database to view our commercial fishing permits over time, maybe look at it now and think about it. This is our new spatial database. This is the original spatial database. There's quite a difference in the number of records. So All right, we have our data now, and we can see these are the communities that have commercial fishing data. So I want you to look at this year field. This year field, I ask you what type of field is the year. In order to visualize data over time, you have to have a field in your database that is actually a date field. We do not have that right now. We need to get a date field that represents our years of 1980 through 2022. So this is kind of a two-step process where you've got to do some Python coding and trick ArcGIS. So I want you to go to add and add a field. We're going to add two fields. One of them is just going to be called temp, because it's going to be a temporary field to get our data first in the format that we want. And it's going to be a text field and a length of 12. Then we're going to add our real field called year 2. Year 2. That's going to be our date field. Okay? And I don't know why that save that. Probably because my number lock is off. There we go. And then hit save. Alright, so date fields are usually month, day, and year. We can't have a date field that is just 1980. It has to be month, day, and year. So we need to create a temporary field that has our data in that format. So go to calculate field for the temp field. And so we're going to have to do some concatenating of information here. So we're going to have to remember this is a text field, so we need 1 backslash 1 backslash and end quote. So we're going to add January 1st and then plus str, which is going to convert our year field into a text field. So what this is doing is it's going to make 1 backslash 1 backslash 1980, 1981, 1982. We have the year was a numeric field, so we've got to convert it into a text with this str function in Python. So once you have this, hit OK. And we'll have a field here that's now in the right format, but a text field. So this should say 1-1-1980, 1-1-1981, 1-1-1982, and so on. Once this gets done, then we can use the field calculator to populate our date field. It'll automatically transform this text field into a proper date field. Okay, it looks all good there. Now come over here and use the calculate field. Delete that. Go down to your temp field. And then use that to populate your year 2 and hit OK. So now we'll have a proper year field that we can use to visualize our data kind of with something that's called this time slider. So notice up here we have nothing. There's no little bar up there. You go back to your Word document here and click on time slider. Open up this time slider here. So time slider is a way to visualize temporal data, And so you're going to see something that pops up that actually can allow you to flip through the years in your data. You know, your data can be by years, you can even have data by seconds. There can be different time settings. We'll look at one that's 5-year intervals, but this slider control allows you to flip through data. You can also, like I said, you know, save this as a movie, but I'm not going to go into saving it as a movie. That's something that you guys could explore. All right, so we have that field. So go up to your permits 1980 2022 COM, right click and go to properties, and then go down to time. All right, you'll see that right now there is no time dimension to your data set. Now that we have the data in the proper format, we have to tell it there is a time component to it. So click on the entire layer as shown within the fixed time extent. All right. And for here, it's actually click on filter layer based on attribute values. One thing that I was noticing is it wasn't smart enough to figure out what my data is doing, so that tells me something isn't right. So click on that one, and then it is smart enough to recognize that we have a year field, year 2, and it goes from 1980 to 2022. So this is what you want to select. All right, click OK. Okay, so now you can see the little time slider up here. Okay, so I'm going to close this down, and you know, I'd recommend kind of maximizing your real estate here, and so I can see this. And now if I go up to time, I can see that I have different options here. I would just hit play and just kind of watch what happens. You can see up here it's flipping through each of the years of your database. Some communities go away, some come back. You can play with this and you can speed it up kind of with the timing here. You know, you can make it go really fast if going through, you know, this many years of data is too slow. You know, nearly 40 years of data. But one thing, I mean, it's not all that exciting, and, you know, at this level. I mean, you can see communities come, you can see communities go. You know, I'm not seeing any clear patterns in this that say, hey, all this rural Alaska communities have gone away, it's all centralized along the road system. So I'm not really seeing that in the data. But then again, we're just looking at, do the communities have commercial fishing permit or do they not? There's no number to this data. So let's work with our symbology here. Okay. Now remember we had that percent field. So let's see. Maybe I'll do graduated symbols. I'll choose the percent column. Okay. And I find just going with the 5 classes that it picks. But again, I'm going to change the colors so that they pop more to me. So I'm going to use maybe a light blue, then a bit darker of a blue, and then maybe a yellow for the center, and then I'm going to use maybe an orange, and then get into a red. I don't know. Just so that, you know, I'm not only having a size differentiation, but I'm having a color differentiation. Okay, so we colored the percents. All right, so now let's go back and hit our play up here. And so now when you visualize it, you can see like the percentage. Are we seeing changes? And we can pause it. So like if we see something changing, like I'm seeing more bigger dots down here in the southeast, I can actually move this and say, hey, wait a minute, I missed it. Let's go back. You can also, by yourself, sit here and go like this. Oh my gosh, what happened in 1984? You'd be like, interesting. All the commercial fishing crashed over here, but exploded in the southeast. I'm not extremely knowledgeable on what was happening, but it'd be something I'd investigate. And you saw it went away, came back for a year. So this is just an example of a way to visualize the data. If people were asking, you know, how has the commercial fishing permit ownership by community changed over time? Okay, and like I said, you can change the years. You know, this is just a single year span, and you could do it in 5-year intervals. So yeah, I'm just kind of looking at any of this other information up here. Okay, so this is one way to visualize it. Another way is to look at the borough level. So if you go to your map and you add data, you'll see that in your student you have borough data 5 years. You will, let me add it, okay. And for this, again, go to Symbology and choose Graduated Colors. And you'll see that I made a field called percent. So do that. And if you look at the attributes of your table, I just did this in 5-year intervals. So you have like 1980, you have 1985, you have 1990. So this is just a 5-year time step. So let's see if our time category is set up here. So we'll go to the properties and time, and no, it is not. So we need to tell it that yes, we do have this time field, and it goes from 1980 to 2020. So we'll hit OK. I'm going to turn off the permit dots. So this is just summarized up at the borough level. So interesting. Here. Not sure why the data has disappeared, but ArcGIS is acting a little strange here. Add on that file again. I could not tell you why it is disappearing, but it is disappearing when I do this. Let me do some exploring here. Okay, I did some troubleshooting, and what I think is going on is ArcGIS Pro doesn't like it when you have multiple layers on there that have a time component to it. So it gets confused as far as what really is, what should the time slider be looking at. Should it have been looking at the communities layer that we had on here that had a time component to it, or should it be looking at this borough layer that has a time component to it? So what you need to do is remove the communities layer that had the time component on it. You know, we're kind of done with it. Take it off. And then go to your folder and add in, you know, this borough's 5-year data. I've already added it. Okay. Now right click on it and go to properties. And then go down and click filter layer based on attribute values, and then hit OK. Go to Symbology and go to graduated colors, then choose that percent. And so this will show you, again, rather than at the community level, summarized by the percent level, which boroughs have the biggest percentage in each year. 5 time steps, 1980, 85, 1990, 95, so on, of commercial fishing permits. Okay, and then you can go up here to your time, and I'm just going to hit play for now. And I think that it's a 1-year time interval, so you're like, what the heck is going on? When it gets to 90, it pops up, 95, it pops up. Not really what we want. So you want to go up here and change this to 5, because you 5-year span, because that's what your data really is. And then hit play, and it should go over a 5-year span period. So there you go. And again, okay, North Slope didn't have any. There was 1 year where it was really concentrated. I'm going to pause it, and we can move this, Yeah, for some reason, like in that 84 or this 85, definitely concentrated down here. Just one word of warning is I wouldn't just look at a single year. So if I did this, maybe I'd do the 5-year average. So 1980 to 84, average that. 85 to 89, average that, because commercial fishing is notorious for boom-bust cycles from each year. But anyway, this is how you would summarize it at the borough level. And again, I had to pull it into into R to do this summary statistics, kind of beyond ArcGIS's capabilities. So this is, the component where we're looking at commercial fishing permits, and now we'll switch into the multi-dimensional raster analysis. Alright, so now we're going to go on to the multi-dimensional data. So what I would do is I would remove this 5-year data, just kind of keep a clean table of contents here. I'm probably just going to remove these standalone tables because I really don't need those either. Alright, so go up to map, add your data, and I will put in it in your student data, but there's this oceans, and you have this ERA 5 July average sea surface temperatures from 1940 to 2021. Actually, it's 2022. Rename that there. Okay. Add it. Oh no, it failed to add. It's fine. Hit refresh. It's going to probably ask you to calculate statistics. Hit yes. Take a while to calculate statistics. So as I mentioned, this is a very large database, and it's going to have sea surface temperature from 1940 to 2022 stacked on top of it. And so we're going to take a look at the layer properties and see what this beast of a data set looks like. Okay, so here we see it. You'll notice that we're in Alaska Alber's projection, so it's kind of wonky when you zoom out. It would be hard to see what's going on with Africa here because Africa is kind of distorted and sideways. There is a way to visualize it more in the standard WGS 1984. But first, let's learn a little bit more about this layer. Clearly, it has some issues with oceans being in countries, but right-click and go to Properties. Okay, it does automatically recognize that there is a time component to it. And the field that represents the time is this STD time column. It's a little weird, but just know that that is your time column in your database. So let's go up to Source, and let's go to Multidimensional Info, and we see that this time field is 83 steps, so 83 years of data. The field that contains the sea surface temperatures is this SSTK at SFC. So this is the data, the variable that we're of interest that's being displayed right here, sea surface temperatures, and this is your time field. Okay, it's kind of interesting. It's a single band data. You'll sometimes see data sets like the above data that I use actually has multiple bands, and each of the bands is a year, but this one is a single band. One thing that's odd, the spatial reference for it is this special GS coordinate system imported in the grid file. It doesn't really tell us what it is, but it have a projection. Okay, so the important thing is to look at the source, kind of look at what's going on there, what fields are, and the time. Alright, so let's, there is no attribute field to this. So we just have to remember that STD, field was the year, and this STK is the actual sea surface temperature. So if you don't, if you wanted to view the entire world, what you could do is you could go up to map and you can insert and put a new map on there, and it'll give you, your standard WGS Mercator's. So you could grab this and drag it over and put it in the new map, and now kind of here's the projection you're probably more familiar with, not specific to Alaska, but you can see the data across the world. Okay, all right, so you'll notice that there's, again, this time is active here, so just go ahead and hit play. And you'll see it start to move through, just kind of zooming in and zooming out. Okay, not surprisingly, the warmest sea surface temperatures are found here, around the equator. Not seeing too many oranges, up by Alaska yet. You can look up here and you can see we're in the 70s right now. We're getting into the 80s. Ooh, I'm starting to see some more tealy colors over here, especially like around here, Bering Straits area. We're getting in the 90s here. Okay. 2000s. I'm definitely starting to pick up some yellow hues here on Alaska. And more recent. So, this is a way to visualize how has the sea surface temperatures changed across 80 years of data relatively quickly in one file. It's pretty amazing. Okay, I'm going to go back to my original map with Alaska here and just kind of zoom into Alaska. Okay, so we have all this data. This is probably something, pretty new, pretty, pretty advanced for ArcGIS, but I think you can handle it. So one thing that we're going to do is, if you have your field highlighted, you can go up to multidimensional and you can see that there are different tools that you can use here. I'm going to pick this maybe temporal profile. Okay. And so basically this is giving us a chart. Remember, it's kind of like your linear chart over time. And properties, here the properties are up. And so I'm interested in a trend. How about let's just draw a box here out in the Bering Sea area. So I'm drawing a box. I can see it says loading right here. Okay. So basically, this is showing me changes in sea surface temperature over time for this geographic region right here. And you can see, what if we put a trend line in there? Click the trend line. Definitely an increase, let's say, in sea surface temperatures over in here. You could also say, hey, I want to compare, this area off in this sea to, let's say, the Gulf of Alaska off by Juneau. So we can come over here, we can click our rectangle again. Let's click a rectangle here off by Juneau. Okay. It's loading. Okay, so now we have 2 areas, and I can come over here and I can right click on this, or I can double click actually, and I could set the transparency a little bit more, so I could see through it, and I can make the color maybe a little bit different. Come up here, double click on this, and maybe set the transparency to 82, but leave it blue. I mean, I can kind of see that this is different, but it updated my chart. So I can see that in general, the waters off of Juneau are warmer, the sea surface temperatures are warmer than what is found over here in like the Bering Sea area. Just looking at our other options here, you could bin it at different intervals. So if you wanted to do 5-year intervals, you can label data points. Wow, that's messy as heck. You can look at the different statistics for the areas. One thing that's interesting is there's no option to show, say, your equation here, your R squared. So, the actual analysis is kind of a little bit limited with this, but you can make pretty charts that then you could, take screenshots of and put in PowerPoint presentations. And you can always check these off too. Yeah. I tried to find a way where we could use some polygons and do some zonal statistics, but it really wasn't working with this data, and so it seems a little bit limited as far as that goes, but we're going to figure out another way to do an analysis like that. Alright, so what I would like you to do is, if you go back up here to the multidimensional, there are these other analyses that you can do, like you can do anomaly. So you can find like hot and cold spots, deviations from the mean temperature over time. Trend will show you where's it really trending up, where's it really trending down. And there was, in some options, there is a predict the future. I'm not seeing an option here of predicting the future. So I would like you guys to, we can do more trends. I would like you guys, there's a trend raster, to run either of these tools. So either the anomaly tool or the trend tool, and see what the map looks like, and then make a nice map, say for the people who are asking where are we seeing the greatest anomalies within sea surface temperatures. If you want to make a map specific to Alaska, if you want to do a map at this world, if you want to focus in on a certain part of the world, Gulf of Mexico, off Africa, it doesn't matter. Just choose one of these 2, do it, and make a map. Have fun, play with the tools. Okay. Alright, so we'll close this down here. So now I want you to add in a file that represents the commercial fishing management areas. So you have these NMF zones. National Marine Fisheries something S. So these are, let me get this out of the way. These are management zones by the National Marine Fisheries Services, National Marine Fisheries Services. And so lots of times permits are offered, by these different zones. Fish statistics, are calculated by these different zones. And so we're going to use these different zones to look at the question of, people are commenting that the waters are getting warmer where they do their fishing. And so probably, maybe the surface, the ocean temperature at 2 meters would be the better data source to grab for that. But for this one, we're just going to use the sea surface temperature data set. So, as I mentioned, trying to do the zonal statistics by this, I think what you would have to do is you have to break up all 83 years of data into a raster that represents each of the years, and then you would have to do zonal statistics using that batch tool that I showed you last week, and crunch the numbers there. But we're not going to go through all of that. We're going to do a different approach. So what we're going to do is we're going to create centroids for each of these management areas, and then we're going to use the option of sample, and that's kind of like, you know, you're extracting the value from this raster to each of those points. So first we need to convert this polygon into a point, and so we'll go over to our toolboxes and we'll say polygon to point. Alright, one thing you'll notice, there is no polygon to point tool. There's only this feature to point. I don't know why, but it works on features within a geodatabase, but it also works on polygons. So we'll open up that and we'll grab our nymphs zones, and we want the points to be inside the nymph zones, and we'll just leave the default value for it and then hit run. So it'll create a point that's kind of the centroid of each of these different management zones. Okay. So I'm going to take a look at the attribute table. There's 25 different management zones. This rep underscore area indicates the management zone, and then you have the sub area where you can see which ones are in the Bering Sea, you know, which ones are off the Gulf of Alaska. Oh, I love the area called Donut. Where is a donut? That is the donut. Okay. Alright, so let's clear this. Alright, so we want to extract for each point what is the sea surface temperature for each of those 83 years. So highlight your multi-dimensional raster, go up to multi-dimensional, go down and hit sample. Okay, so input raster is our single multi-dimensional raster. We'll do our feature to point. Process is multi-dimensional. I do want to check generate feature class. Okay, and for the statistics I'll just choose mean. Okay, and then hit run. Alright, so sample completed with warnings. The sample location do not have a spatial reference. The spatial reference of the rasters will be used. So to me that's like a red flag. So I'll look at my data. You know, and I do have, you know, remember this STD time, that's our years, and look, it's very strange, these years. It does not look anything like 1940, 1941. We'll get to that. And our STK at SF, this is supposed to be our sea surface temperature. I'm seeing a lot of nulls here. Yeah, to me it looks like this didn't work. It has not extracted any sea surface temperature to this. And I'm thinking it has to do with this warning. So I have asked you, before moving forward, pause the video and think about what is gone wrong with our analysis. Why is this not working? And I don't want this just copy and pasted as your result. Think about what this is telling me, and where should I go to figure out what, you know, what's wrong with my point feature. Okay? So think about that. Alright, so I'm going to delete this off because it's not working. And I'm going to delete off this feature point. Something's wrong. Okay. So hopefully you've thought about it. This to me is telling me there's something wrong with this spatial reference. There's something wrong with the projection of that point file that I used. That point file was based off of this nymphs zone. So something must be wrong with this one. So let's go to the properties of this and let's look at the spatial information. So go to source, go to spatial reference, I ask you, what is the coordinate system for this? It has no coordinate system. Whoever made this was very, very sloppy, and they didn't even provide projection information for this file. That is really bad GIS work. So this needs to have a coordinate system assigned to it. I don't know if it's collected in WGS 84, if it's Alaska Albers, I'm not exactly sure. But for this case, we're going to assign it a projection of Alaska Albers. I mean, how can you do a spatial analysis if you have no coordinate system to base where you're extracting points from? It needs to have this. Alright, so you've never done this before, and this is a big thing in differentiating between changing a projection and assigning a projection. So we're going to go to Analysis and Tools. And this is where I think it's important to understand where your tools are. So it's under Data Management, and you go down to Projection. And you'll see there are these tools of Project and Define a projection. You guys have been using the Project tool, which will take an existing shapefile that has a projection and change it into a new projection. Our problem is this data set doesn't even have a projection to start with. So that's why we have to use the Define projection tool. This will actually modify your data set, whereas the projection will produce a new data set. Say you had this in Alaska Albers and you wanted it in WGS 84. It will create a new file with a WGS 84 projection. This is going to directly modify our data. So, what we want to do is choose this data set, and we don't want an unknown coordinate system. We actually want Alaska Albers, so I'm just going to choose the communities that's on here and steal the Alaska Albers, and then I'm going to hit run. So this is actually modifying the data set. So now when we go to this data set and we look at the properties, it has a projection to it. Okay. So now let's try to do our sampling again. So one quick way is to go up to Analysis, go up to History. We can see we tried to do our sample here. Let's double click on it. Well, actually we need to first create points from this. So we did Feature to Point. Double click on that. And we'll just rerun this again. And when this gets added to our table of contents, let's look at it and make sure that it does have a coordinate system with it this time. Okay, it's added. Okay, it does have a coordinate system with it this time. Yay! Alright, hit OK. Now again, go back to your analysis and let's view our history. Now let's run the sample. Okay, so we're using that same feature, but it has a projection now. Everything else kind of remains the same, no need to change any of that. And now hit run. And hopefully this time we will actually have sea surface temperatures for each of our points. This might take a little while, which kind of is good. It seems like maybe it's working better this time. Alright, so it completed successfully. No orange warnings down here. For me it took 2 minutes and 46 seconds to run, so it takes a little time. Alright, so I'm more hopeful. Let's take a look at our new point file, attribute table. Yay! Now I see some values for the sea surface temperatures. We have our time and we have our dimensions. Okay, so I noted that You know, this time is really funky. I mean, it's I don't know why they chose these numbers like they did, but they did. And you just kind of have to know that this first time, this corresponds to 1940, 41, 42, 43. And one way that you can tell is like this is what, 147930. Let's go down to the next location ID, and it should start with like this 147930, 15158. So let's go down. Here we go. Yes, 14793, 158. So it's wonky. But you know, it is our data, so let's, you know, say that we're going to run with it for now, and we want to visualize how each of these, how this is changing over time. So we want to go up to data, create a chart, and let's do a line chart. Okay, and so just knowing our data, you know, this STD time is the actual time field. For the aggregation, we're going to put none, and our numeric field is this, which is our sea surface temperature, and we'll hit apply. Okay, we're going to choose mean. There we go. So that gives us like the mean sea surface temperature, you know, for all of our, what was it, 25 NMF zones over time. So, you know, we can see a trend here. It does look like it's going up. We don't have the option to add a trend line to this, which is something I think they're sorely missing. I'm just looking with these charts. But okay, so, but this isn't very useful for the public. What, a year of 16,000, a year of 18,000? I'm not even sure we'll have a planet by then, but this isn't very helpful. So this is where, you know, we've got to do some tips and tricks that are outside of ArcGIS, because it's just, it's not intuitive. So let's go back to our data here, and I want you to export this as a CSV file and save it to a place on your computer where you can find it. So I like have a temp folder here. Okay. And I'm just going to maybe call it SC surface temperature SSC times.csv. Okay. And hit save. And then hit OK. So what we're going to do is we're going to actually end up opening this up with Excel. And we're going to create a key that allows us to figure out what this STD time is in real years. So thinking, and then I'm going to hit OK, and once this kind of comes back to life, it'll export. Alright, so we have exported it. I'm just going to remove it from here because we're going to actually open it in Excel, and I don't really want it in my project when we open it in Excel. Move. Okay. Alright, so I'm going to navigate to where I saved that and open it in Excel. I can double click on it. The computer knows that you open it in Excel. You know, if your computer, you should know how to open CSV files by now, but you could also go here and you could go open and you could browse, and you would have to change this to all files, and then it would show up. There it is. Okay, I'm not going to open it again because I have it open. So, alright. So we see that we have our STD time, our less than useful column to represent the time field. So I'm going to add, you guys should add another field called year. Okay. And so I know this date is 1940, and it's going to go down to 2022. So I could go like this in the corner. I click and I drag. But what I really want to do is I want to add a year every time I scroll down. So hit the control button, and notice how that turns to a plus. And now it's going to add up the years without me having to do anything. And I'm going to hold my mouse clicker and drag down to 2022. And let go. There we go. So it populated 2022 all the way back up to 1990. So one thing that I'm looking at is I'm going to highlight the data that goes from 2022 all the way to 1940. So I'm going to copy this and I'm going to come down here and paste it just like over here. And actually I want it one up, because what I'm wanting to do is I'm wanting to make sure that, okay, again, we're starting with our sample location 2, our NIMP zone 2. Indeed, we had the same ordering. One hack to check is you can do equals, 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 and if it's true, double click, then they all match up. And they do match up. So when I get to the bottom of this, I should start with point number 3. So I'm very confident that this key that I've developed, linking together this STD time with the year, is correct. So now I want to save this key. So I'm just going to copy this chunk of years here. Okay, copy it. Open up a new Word Excel, paste it. Okay. I don't really need this dimensions field, so I'm going to delete it. All I want is this key linking this useless STD time to my year. So now I have my key. Alright, I'm going to go File, Save As. I'm going to navigate to that like temporary folder where I saved the other one. You navigate to wherever on yours. I'm going to save it as a CSV file. ArcGIS does not like Excel files. And I'm going to call it SST underscore year underscore key. Okay, so this is going to be your key. And I'll hit save. Okay, so now close this down. Close down this other one. You don't need to save your changes. Don't save. Alright, now go back to your ArcGIS Pro. Add this CSV file that you just made. Navigate to wherever you still stored it. Date modified. Here it is. Okay. Now to my sample location, I'm going to add a field called year. So our sample points here. Year. I can spell. Year. Year. I'm going to leave it along. Okay. Hit tab. Yeah, long. Go up to fields. Hit save. Now I'm going to join this key to this table. Okay. So, because I want to get a year field over here, so we're going to have this highlighted, go up to table, go up to joins, and it's chosen our SST year key. Now the field in common is this STD time, okay, and hit OK. And now we can use this information to calculate our year field that's stored in our database. So choose your joined year information. Because our goal is to make a chart that's more understandable by the public, that has the real year instead of this STD time. Alright, then go and remove the join. Okay, so here was kind of our useless table chart, and so close this one down. Now let's make another one. Let's see, table, let's see. Oh, go away. Actually, it's just easier to right click on this and go to create chart and line chart. And now we will choose our year field instead of that other one. And we'll choose mean. And our field is still the sea surface temperature, and hit apply. And now we have a table that's much more user-friendly, and we can see, you know, that you know, the years across the bottom. You know, if I was making this for the public, I might see if I could play around and figure out how to not to have commas there. But I'm not going to mess with that right now. So I want you to take a screenshot and copy, you know, yours over. One thing, getting back to our question of which, you know, NMFS area has the, you know, which NMFS area has the highest sea surface temperatures, which NMFS area has the lowest, because, you know, we're thinking that there's something to be learned from the areas that are already, you know, have high temperatures. So if we're expecting like the high temperatures to shift into areas that have low temperatures, we can look at what those places are doing right now and kind of learn from them. So which areas in our NMFS zones tend to have the higher sea surface temperatures? You can use this split by option here and split by location ID. And yes, there's going to be 25 unique values. So there's 25 NMFS areas. Okay. And so we can see that this one here, 22, is the highest, but we're like, oh, which one is 22 here? We can go over to our sample and we can do labeling. And then we can go up to labeling. And our labeling, we want to be our location ID. Okay? It might take a little bit of time for it to draw the labeling off of it. I'm going to turn this off for now. Oh, I have to hit unpause. That usually helps so that it draws. I had it paused to get things to process faster. So now it should label each of these points. Okay, and so we can look for 22. Oh, there's 22. So I want you to tell me which of the NMFS zones has the highest sea surface temperature, which two. So I don't want to have you tell me the number 22 and the number whatever this other one is here. I want you to figure out what is the actual name of these zones, not just the point number. So you should be able to figure out what is the name of that NMFS zone. And so maybe these ones that are on the bottom have something to learn from the ones that have already been dealing with warmer temperatures. You know, what kind of fish typically occur in these NMFS zones that have warmer waters? What kind of permits typically happen there? Okay. And so just one last thing, you know, if this analysis is just looking at one point within this NMFS zone, not really very robust. You know, if we were doing this for real, what we'd probably want to do is put multiple points within each of these NMFS zones and then do the process of sampling. There is a tool where you can add random points to each of these NMFS zones, and then you could do the sampling process. So we're not going to actually do the sampling process, but I do want to show you how to create those random points in case you need to do that, you know, in future analysis. So go to Tools, and we'll type in random points. And so we have this create random points, and double click on that. And we'll just call this, you know, output NMFS random PTS. Okay? And so what you can do is you can say, I want them to be done within our zones, And for this example, just do 10 so you can actually see it. 100 gets kind of difficult because you have 100 crammed into here, you know, versus 100 crammed into here. So there is the issue of you're going to have higher sampling intensity in areas that are smaller versus areas that are bigger. But you know, we'll just ignore that for now. I mean, you can just do this. And so this is a way to create some random points, more points within each of the nymph zones. And then you would rerun your sample tool on, say, this updated point layer. So it's running and creating random points. So okay, so you can see, if you zoom in here, I don't want to do that. Zoom in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are in there. In here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in fact, it did create 10 random points within each of these nymph zones. So like I said, I don't want you to do any analysis with it, just something to know. And that's all for this week's exercise. Hopefully you guys enjoy it and find the visualizations really interesting and increased awareness of different data sets that are available here in Alaska.